In today's video, we're going to be looking at equations of circles. Now, let's take it back to basics. When you're thinking about what a circle is, it's actually always going to have a center, and the edge of the circle is always going to be the same distance away from that center no matter where you measure it. So our official definition of a circle is the set of all points, otherwise called the loci of points, that are all equidistant and equal distance. So equidistant from a center point. And we've already talked about what a radius versus diameter means, and basically all that means is no matter where you draw it, the radius of your circle is always going to be the same length. Think about how you could actually construct a circle with a compass. That's another way to think of a loci of points as a set of all points that hold that particular behavior or property. So let's see what actually makes the equation of a circle. And we're going to go back to what we studied during our second unit during building blocks and just look at the distance between 2 points, because at its basics, the radius of a circle, again, it's just the distance between a center and an edge point. But specifically, we're going to use the points that we have in the diagram, so HK and XY. So the distance, again, distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So the differences of your x's and the differences of your y's. So what I'm going to do for this problem, though, is I'm going to pick a very specific order of the points that I'm going to use. So I'm going to call my initial point in the middle, my center, I'm going to call that point 1. And my extra point on the edge, the xy, we're going to call that point 2. And let's go ahead and just fill in our values. And we also have our radius marked, so we're going to call that r. So let's just substitute into our equation. So our distance, our radius, is equal to the x-coordinate of our second point, aka x, minus the x-coordinate of our first point, our h. And we can do that with the y as well. So y-coordinate from second minus y-coordinate from the first point, the way we have them labeled. Now, we don't usually like having that big square root in there, so how could we get rid of that? Well, to solve something out that has a square root, to undo that square root, just square both sides, kind of like what we do for, simplifying distance formula or solving for kind of the opposite of solving for Pythagorean theorem. So squaring both sides, we're going to have r squared equals, and then just gets rid of the square root. So x minus h squared plus y minus k squared. And if I actually switch those orders, so I'm going to write the larger amount of that equation, the longer piece on the left, y minus k squared equals r squared, then that formula actually is what we can use as the formula for a circle. It really is just the distance formula, but kind of tweaking it a little bit for the values, the exact points that we're using. So let's look at this a little bit more specifically in terms of definitions of that circle. So if we're given any circle that has a center, again, we called it HK, and a radius, which we still called R, the equation it's stated as, or what we could actually plug into Desmos if we graph it, and a note on that in a second, is we could just plug it in exactly as is, x minus h squared plus y minus k squared equals r squared. Now you'll notice I made that note that we could graph this on Desmos. If you're using a TI calculator, unfortunately, you can't graph a circle equation straight out on the calculator. Reason being, if we go back to Algebra 1 and thinking about graphs and how we can test whether or not things are functions, here's our problem with a circle. Our function test back in algebra, let me change my color. So our function test in algebra was you can put a vertical line anywhere on your graph and it should only touch one time. Well, if I put a vertical line on my circle graph, it touches 2 times. So unfortunately, this is not a function. And when you're using a TI calculator, you can only plug in function equations. You have to go to the screen y equals. And our equation definitely is not in y equals format. But if you're using a Desmos calculator to check your work, you could absolutely just plug it in as is, and it should graph your equation. So not a bad thing to test out. So after we've done some of the examples in the video, feel free to do that. Test out some of the examples, see how you can plug them into Desmos to double check your graphs. All right, so let's check out some examples. Here we go. So first example, write an equation for a circle with center -1, 3 and radius 6. So again, we're going to plug just into our formula, and our HK, our center, where we get our H and our K from. Again, we're just going to plug those in as is. Radius is 6, so that's your R equals 6, like we have in the directions. So starting with your generic formula, X minus H, and you do have it written down in there. But again, if you're not using a printed version of your notes, I'd go ahead and write this out completely with the equation. So let's just plug things in. So we're going to plug in H is -1. K is a +3. And our R is a 6. And then we're going to go ahead and simplify everything. In our first set of parentheses with the X, we have a minus a -1, which really simplifies out to a +1. No changes on the Y, we just had Y minus 3, so the parentheses that we used for substitution don't really mean anything, so we can take those out. And then 6 squared is 36. So that's the equation of our circle. But given that information, where our center is and where our radius is, we can also graph a picture of that circle. Let me go ahead and switch over to red so that'll pop a little better. So your center is at -1, 3. So plot your point -1, 3. There's your center, HK. And then you have a radius of 6. So that means from every single direction, the loci of points that are all 6 units away from that center. Well, let's just count out left, right, top, bottom, and sketch in the circle. So over 1, 2, 3, 4, 5, 6, up 6, which is right at the edge of the graph. That's okay. And same thing, 6 left, right at the edge, and down at the bottom. And I'm not going to be able to draw a perfect circle. So a lot of times when I draw circles this way, they kind of look egg-shaped. Maybe they're a little too flat or a little too pointed in one piece. But if I've gone ahead and graphed out my center and I've graphed out those extra points, anybody looking at that picture knows I was trying to graph a circle, and they can very easily find what the radius is just by comparing those points. Alrighty. So let's keep going. We're going to look at a few different ways to approach these, but it's all using that same basic equation. So you try examples. So we're going to do 1 and 2 together, and then you try out number 3. And same thing, we might leave some of these out for you to try on your own after you finish the video. Okay, here we go. So write an equation for each circle. Again, our basic equation. Never a bad idea to write it out until you have it memorized. And again, notice where our signs are. Inside our parentheses, we have a negative sign. In between our parentheses, we have a positive, and our R is always squared in the formula. So in our first problem, center at 0, 0, R equals 8. We just plug that straight in. So X minus 0 squared plus Y minus 0 squared equals R squared, or 8 squared. Simplify it out, but what happens when you subtract anything by 0? Yeah, all you get is that starting value. So this is really just going to be an X squared plus Y squared, and 8 squared is 64. My brain was jumping ahead to the next step. There we go. So center at -2, 3, radius at 5. Okay, so we plug in X minus -2 all squared plus Y minus 3 squared equals 5 squared. Simplify out with that -2, and we really have X plus 2 squared plus Y minus 3 squared equals 25 squared. And again, notice I'm not trying to distribute anything out. I'm not trying to multiply out those parentheses that have the squared in there, because when we look at a circle equation with the format that we're using and the format that, if you have to take the SOL, that you're going to see on that test, they're always going to leave these inside of parentheses. So we don't have to go any further than that. It's really just plugging our numbers into the format. That's all this is for writing an equation. Okay, so number 3, I said I was going to have you try this on your own, but let's go ahead and do this together. Because I'm noticing something a little different on this. So reading through, center at -2, -6, diameter equals 8. Wait a second. If the diameter is 8, then does that tell us anything about the radius? Oh yeah, don't forget the radius of a circle is always going to be half the diameter. We talked about that a little bit in our warm-up problem with circles. So for this, our radius is actually 4, and that's what we're going to want to plug in when we do this problem. So plugging in x minus a negative 2 all squared plus y minus a negative 6 all squared equals 8 squared. And again, notice I'm taking the time to write in the negatives. I know once you get more practice with this, you may not be able or may not need to do that, but you always want to be careful that anytime you're plugging in that negative, like negative 2, you do end up actually switching the sign in your final equation. So, I mean, if you can skip that step, awesome. If you want to take the extra step of writing everything out, then simplifying, that'll ensure that you always have a chance to double check your signs and double check that you went through and found the correct radius and that you squared it for your final answer. Alrighty, so sometimes you're going to go the other direction. So if you're given information about that circle or about that equation, maybe then figuring out, well, what's my radius? What's my diameter? What's my center? Things like that. So in our second set, they give us the equation and we've got to state some more information. Specifically, find the center. In other words, find your HK value and find your radius given the equation. So in number 4, your circle equation is x squared plus y squared equals 20. So if we're comparing that to our generic form, and which we have up at the top of the page there, well, wait a second, we have an x squared. How are we going to get an h out of that when I don't have an x minus a number? Well, think about what we did in example 1. If you subtract 0 from something, then you get that starting value again. So if I technically am subtracting 0 from the x, I would just get an x squared. So my x coordinate h is going to be 0. What about the y value? Well, same thing. We just have a y squared. So the only thing we could have subtracted to end up with that would be 0. Now your radius squared, keep in mind our generic formula, we're always going to have equals radius squared, and that's set equal to 20. So I need to do a little bit of thinking here. If r squared equals 20, well then how can I figure out what just the plane r is? What do I have to get rid of? Actually I need to go in and actually take the square root of both sides. So that's going to leave me with the square root of 20. But thinking back to when we did a little bit of simplifying in our right triangle unit, we need to actually simplify this out. So square root of 20, are there any perfect squares I can factor out? Well, yeah, 20 is the same thing as 4 times 5, and 4 is a perfect square. So I could actually write that as 2 root 5. So that is going to be my radius. Alrighty. Again, depends on the problem. If you see a problem that says, round your answer to the nearest tenth, well, then it's asking you for the decimal version of that. And so in this case, square root of 20 would be something like a 4.5-ish when you take the square root on your calculator. Okay, number 5 is a little more straightforward. So x plus 4. So again, comparing that to our original equation that we've got up at the top of the page, we'd have to do x minus a number to get positive 4. Well, what's the only thing that can flip it over to a positive? That's right, negative. So even though you may not necessarily need to write the step, you want to think, well, this is the same thing as doing x minus a negative 4 squared. And to get the y plus 3, well, it must be y minus a negative 3 squared. And the 16, well, again, if that's r squared, what do you square to make 16? Well, that's a 4, so that's really 4 squared. So that means our center on this one is going to be negative 4, negative 3, and our radius is going to be 4. I actually didn't label the center over here, so let's go ahead and do that. Alrighty, so last set of examples is just graphing the equation graphing the circle from the equation. So here we go, 6, 7, and 8. And I'm going to go ahead and let's write out our reminder, x minus h squared plus y minus k squared equals r squared. Okay, I'm going to flip back over to red because that's a little easier to see. So again, each one, if you can determine what your center is and determine your radius, you can graph your circle. So what's your center for number 6? Well, again, x squared and y squared, what would you have to subtract to just get a plain x squared? Well, that's going to be a 0. So our center on this one is 0, 0. Your radius, if radius squared is 16, like in the last problem, that means your radius is actually going to be 4. So then graph it out. Graph your center at 0, 0, and then count out 4 spaces in every direction. So 4 to the right, 4 down, 4 left, 4 up, and then sketch in your circle. Again, it doesn't have to be perfect. And you're probably thinking, well, how am I going to do this online? Well, we're probably going to include a Desmos calculator in your test at some point, so you can check your work. But a lot of this is probably going to be recognition. So if we give you an equation, can you pick out the correct graph of the given options? Or can you describe the correct graph? Can you describe the center? Can you describe the radius? So you still need to be able to recognize a graph, but make sure or think about the fact we're not going to be able to have you do a whole lot of drawing potentially. Okay, number 7, x plus 2. So what should be your x coordinate for that to get a plus 2 if you have x minus h? That should be a negative 2. So that's our center. And then what about y squared? Means your y coordinate is really 0. Okay, if 4 is your radius squared, that means your radius has to be 2. So graph the point negative 2, 0. There's your center. And then count 2 out in each direction. So 2 right, down, left, and up, and connect your points. Alrighty, last one. Here we go. So x squared means your x coordinate for your center is going to be 0. Y minus 1 means your y coordinate will be positive 1. And 9 for r squared means your r, your radius, is really 3. Plot your point, 0, 1. And then 3 out in every direction to draw your circle. Alrighty. As always, let me know if you have any questions. If not, go ahead and get started on your Desmos activity, which will give you some practice. Talk to you later.